For the e-commerce website, the scope of this assignment is to implement different models to multinomial logistic regression. This assignment has 4 categories on this online store that will check the user action for all 4 categories. Okay, first of all, the steps that I follow is that import and insert the data, create a binary table with one photo and code, split the data to train, validation, and test, feed the models, and try to prove the L2 and L1 regression with the lambda that I thought that was more right to give me best error. This is how the data looks like before we implement the one photo code, and this is actually how I implement the one photo code for the categories for the features that we needed. As we can see, now we use all the user actions. Okay, we split our data in train 60%, validation 20%, and test 20%. And now try to feed the model. This is the classification. That gives me the error of 0.7 and for the train test, and 0.78 for the validation rate, for the validation. This is my L2 regularization for my validation and the train. That gives me a really low level for any lambda, 0.75 for the train, and 0.57 for the validation as well.
Mm-hmm.
After that, I try to implement the L1 regularization. That it gives me even worse the error. The train for my train is trained the model with 0.16 and the validation 0.75. And after I try many things, so I try to fit my model for the L2 and L1 for with the lambda that with a small lambda. So for lambda equal to 1 actually gives me the best error for the train, 0.88, and the same for the validation. And I did the same for the L1 regression that gave me this almost same error.
So what is it that you're doing? So where your plots aren't really labeled, and so I kind of can't really tell exactly what it is that you're doing with each one of these.
Actually, here I try to implement with lambda equal 1. I check for all the lambda in the beginning to see which lambda give me the best error, and actually with lambda equal 1, I find that it gives me the best error.
So so the vertical axis is J.
Yeah.
And I assume that
J. This is validation. This is train.
Okay, that's interesting. Okay, yeah, that makes sense. And then, so what's the horizontal axis?
What's the horizontal axis?
Yeah, so the x-axis, right? Horizontal axis. What is it for this graph?
This one.
What is 0, 20, 40, 60?
Yeah, 0, 20, 40, 60, 80, 100. What is that?
This is actually I did the validation. The validation and the train.
Yeah, but what did you do to them?
I'm implementing the code that you gave us.
So this is that you've got your L1 parameter, your lambda 1.
This lambda is equal 1.
For all of these?
Yes.
Then what's the horizontal axis? I don't understand.
Actually, I don't know. I just implement.
Well, no, because this code that we've been writing up here is that you should be changing lambda, and then your horizontal axis should be different values of lambda. So we should be looking at what happens to your training and your validation error
like
as you change lambda. And you have plots where it looks like that's what you did. So like go back. It's like like this one and the other one that's like that. So that looks like that's what you've done.
Yeah.
is that we're checking your J value against different values of lambda to find the best value of lambda, but then you've got these other ones where your errors just more or less seem to be horizontal the whole time, and I don't know what you're doing for these. Like, how did you make
I
this?
just did the for one. If I checked just for one lambda.
But so does that mean then that the horizontal axis is lambda?
Yeah.
So that's strange that it wouldn't really change it because your lines are awfully horizontal, like they're awfully flat. And this is completely contrary to the other plots that you've shown us that show that actually your error goes up as lambda goes up, because now it's looking like it just kind of doesn't do anything. It just looks like there's some noise, but then it more or less stays horizontal as you change lambda. You know what I mean?
More or less.
That's what that graph would tell us.
Yeah. So actually, we don't need to do that.
So this graph and the other ones that are like this that you're showing us actually would kind of indicate that regularization has no effect on your model whatsoever,
Okay. So
which
we
is very
don't need.
strange, because it should definitely affect your model a lot. So like I believe the other ones, like these other graphs,
The first graph.
like
This
that one,
yeah.
I believe that graph, and then the other one,
It's more or less the same.
yep, I totally buy it, right?
Yeah.
Totally makes sense. These other ones though, where everything's just like horizontal more or less, like I have no idea what you've done to generate those graphs.
I told you I did instead of doing the loop, I did it for lambda equal 1.
So you just fit for lambda equals 1 like
Yeah.
over and over and over again?
Yeah. Does it make sense? Because
No.
give me the
Because like what does that do? Like how, and also how is anything changing? If you're just keeping lambda the same, I don't understand like why anything would change.
I don't know that. I just instead of the loop, I did just for lambda equal 1.
Okay, but how'd you get a plot then? Like that's the thing. Like I don't understand what's happening in the plot. Nothing's labeled. Nothing's telling me like what I should read out of this plot, and you're not really explaining it either. So
Do you want to see my code?
no, it's because it's a presentation, right? Like
Yeah.
you're supposed to be able to communicate to people what you've done,
Yeah, I know.
and you don't want to ever be in like a boardroom with like your clients and have them be like, "This graph you're showing me doesn't make sense." Like you can't be like, "Oh, well, do you want to see my code?" Because like, they don't know what the hell your code says.
Actually,
So,
the last two graphs was just experiment. I tried to.
Okay.
I didn't. I was like here, and I
but if
said.
you're going to show people something that was like an experiment, you at least
Yeah.
better be able to explain what the experiment was
Okay.
and like why you might be doing it.
Yeah, I explained that this graph actually show for lambda equal 1.
But then what else is changing? So if lambda is equal to 1 always, then it makes no sense whatsoever to say that the horizontal axis is lambda. So the horizontal axis must be something else. So what is it?
This one, right?
No, that's the vertical axis.
This one.
Yep. So what is that axis?
I did for the train
Mm-hmm.
for the J train and the J val.
So you just did a whole bunch of iterations of training the model, and then fitting, and then checking the error against the training set and the validation set. But you use the same lambda every time.
Yeah. The code is
Like I
like
just don't
that.
even know what that would tell you. Like I just really don't even know like what was your idea in
To
doing
get
that?
a better error.
But if you're not changing anything, why would your error be better? And I mean, you can even see there's like some noise in what you're doing, like there,
Yeah.
but you know, it's not like a perfectly flat line. But like, if you got rid of your noise, like you'd have a perfectly flat line. Like you can see that it's like literally with each of these iterations, it's pretty much doing nothing to your model.
Yeah.
And then any of the noise probably again just comes from like the slight variations in like how your weights were initially randomized. And I bet actually if you set a seed to control for that and make it so that your weights were starting at the same place every time, you would have a perfectly flat line. You know what I mean?
Yeah, yeah.
So like if you're not changing anything, if there's no parameter or hyperparameter that you're changing and you're just like fitting the model over and over and over again, like I would expect that you'd actually see pretty much the same result every time, which is what you saw. But I don't know why that would like help you diagnose anything.
Oh, okay, okay. And actually, after I wanted to ask you what I asked earlier.
Okay.
After that, what we do? We do the validation against the test, right?
Yep.
Okay.
So like pretty much exactly what Felipe did
Yeah.
is like the correct thing, where it's like you fit the model in an unregularized way first.
Yeah.
Then you try and increase the
Lambda.
different lambdas
Okay.
one at a time. and then you just see how does the model react to
The
this.
diagnosis.
You see that the model actually, the performance gets worse,
Yeah.
right? And I think he used a couple metrics, right? Use error and classification rate, and that like by either measurement, the model just gets worse when you regularize it more.
Yeah.
So you would conclude that you aren't going to regularize the model, and so and then you would conclude that since your model only gets worse with regularization, it seems like if anything, it's high bias, and that if you would like to improve the performance, you need to increase the
So the
variance.
result actually from all the presentation was that to tell you that
Yep.
actually,
That okay.
okay.
Seems like we need to increase the variance of our models.
Because at the beginning I thought that was we would have the right error, right result. So I didn't thought that maybe we just need to test it and to see if we need where by high bias or variance situation.
Yep. Yeah. No. So what Felipe did, the diagnostics revealed that the model is at the very least not high variance,
Yep.
and it's probably high bias,
Yeah.
right? Because it would be tough to buy or tough to sell to your team of people that your model just by chance actually has the perfect balance of
Okay.
bias and variance.
Yeah.
So if we're increasing the bias and that's making it worse, then the thing we should try next is to increase the variance somehow.
Okay.
And that it actually seems like it would be quite tedious and quite complex and possibly even intractable to increase the variance by engineering more features. And so we probably just want to build a neural network next, which you guys don't know how to do. But
And more or less that was my presentation.
okay, all right, very nice. Gaston, you've got 10 minutes.
Yeah.
Can I use it?
Yep, go ahead.